What's poppin', dogs? Mr. Allen here, working with some vectors in this video, specifically finding the angle between two vectors. And I got two examples of this here, a twofer, all right? Let's get after it. There is a wonderful formula that'll allow you to find the angle between two vectors, which is what we got to do. And it goes like this. Cosine of theta, theta being the angle between those two vectors, equals the dot product of the two vectors, so A and C. So the dot product of A and C divided by the product of their magnitudes. Okay, not the dot product. No, they're separate, right? Okay, so we got magnitude of A times the magnitude of C. Okay. Now, you may have seen two lines for magnitude or just single, like absolute value bars. I've seen that notation interchangeably, so just be aware of that. This here, or just single bars, means the same thing, at least as far as I'm concerned. All right. So now let's put some things together. Let's put some numbers in here, right? So the dot product of A and C. Well, let's see here. We'd have A and C. So -5, -3, that's 15. And then -12 and -11. What is that? 132? I'm going to type that in just in case. Times 12. Yeah, 132. Okay, cool. All right, so plus 132. All right. Yeah, both are negative. Cool. Okay. It's a scare. All right. Now for my magnitudes. Oh, this is wonderful. All right. My magnitude of A, that's a 5, 12, 13 triangle. So that's 13. But for C there, I am going to have to do a little bit of work. I'll do this in a separate color, a little bit of side math here. We've got the square root of, we got 3 squared plus 11 squared. So that's 9 plus 121. That's the square root of 130. I got that one in my head, right? So 121 plus 9 is 130. Lovely. And put that back in green. Okay. So there we go. Now, that's what the cosine of theta equals. So how do I just get theta? Well, if we take the cosine inverse, that would cancel out, right? The cosines leave me with just theta. So I got to throw all this in my cosine inverse. And I'm going to rewrite this nice for us here. We're going to have the cosine inverse of 15 plus 132. What is that? 147. You don't have to do that, but I'll just do it. And then we got 13 times the square root of 130. That's what I'm going to type in my calculator. And make sure that you are indeed in degree mode if they want degrees, or radian mode if they want radians. I am currently in degree mode, and that's what I'm going to stick with, all right? So we're going to do second cosine. And if you'd like, you could do a fraction alpha x. You can just type it in exactly how it looks. 147, arrow down, 13 times the square root of 130. Square root 130. Cool. Arrow all the way out. Enter, and I get 7.63. That's really, really close. I guess, you know what, they are both negative, so they're kind of going that same, right? That same negative direction there, right? So probably a really small angle. Okay. So we've got final answer. I guess we'll do theta. Final answer is 7.365 degrees. Yay. That's my angle between those two vectors. All right. Cool. That was fun. Should we do this one? Let's do it. Okay. So let's see if we can write it all out on the fly. Okay. We got cosine of theta. We can even just type it all in a cosine inverse, right? I'll start with the cosine of theta. So we have the dot product of B and D. So we've got 7 times -4. That's -28. And then we have plus -24 and 3. Was that -72? Right? Everybody? Yes? Cool. All right. So, and then we have our magnitudes, right? So the magnitude, ooh, this is great. 7, 24, 25. 3, 4, 5. Nice. Pythagorean triples come up a lot in here, all right? Now, I'm not even going to do any of the arithmetic here. I'm just going to throw all this into my cosine inverse, okay? So just bust out the calculator. Like, write that at least, okay? Maybe show that you're taking what? We could show that we're taking the cosine inverse. So I can be like, all right, check it out, man. We got cosine inverse of, appease the people, -28 plus or minus minus 72 over 25 times 5, 125. Or just type it in as 25 times 5. It's up to you. And there we go. Okay. So maybe show that you're doing the inverse. So let's see here. We got alpha x fraction. Negative 28 minus 72 over 5 times 25 or 125, whatever you want. I'm just showing you can type it all in. You don't have to do any of the arithmetic yourself. You got the calculator there anyways, right? Hit enter. 143, a much larger angle this time. I like it. Well, let's think about that too, if that makes sense in a way, right? 143.130, so 0.130 degrees. That is my theta. Theta, equals. There we go. Let's see. B is in the, it's positive in the net. So this is in the fourth quadrant, and then negative, positive, it's in the second quadrant. So like our vectors are looking something like in the fourth, 7, negative 24. So it's going like down quite a bit, right? This is negative 24. This is 7. And then the negative 4, 3. It's looking like maybe more, not quite as vertical. Whatever. Hopefully you get the picture. Something like that. Boom. So then our angle is this guy right here. That makes sense. It's quite obtuse, yes? All right. There we go, guys. Angle between two vectors. Keep this guy in mind. I think it's an easier one to commit to memory. Dot product divided by the product of the magnitudes. Cosine inverse of that. Easier said than done, but with a little bit of practice, you'll hopefully remember that one right there. But that's about it. All right. Have a wonderful day, you guys. Thanks for watching, and see you later.